There are many failure stories about space missions. There are many missions that did not succeed despite spending a lot of money, but people do not stop. I was talking about the space elevator. Space elevator refers to a tether or a long chain that will extend from the Earth's surface to space. Various electromagnetic vehicles can move people and various types of heavy goods. At present, the cost of sending goods through rockets is about $22,000 per kg, but if space elevators are used, it will come down to $200. We still dream or hope that one day ordinary people like us can travel in space with the help of space elevator. Space elevator literally means an elevator to space. It sounds like a science fiction, but in reality research is going on, and this research is not new for about 1.5 years. People are already thinking about making such an object. What is a space elevator? Space elevator theoretically refers to a tether or a long chain extending from Earth's surface into space in a structure whose center of mass would be in geostationary orbit at 35,786 kilometers above Earth's surface. Here the geostationary orbit is the circular orbit whose period is 24 hours, that is, the period of the Earth is equal to the period of the Earth. Different electromagnetic vehicles, people, and various types of heavy goods can travel through this path. Although rocket is the only way to travel in space, this travel can be carried out by elevator at a much lower cost and safely will be possible. Space elevators were first conceived in 1895 by Russian scientist Konstantin Tsiolkovsky, who was heavily inspired by the Eiffel Tower in Paris. At that time, many people thought such a theory was foolish because the strong structure required to create such an object can only be found in science fiction. Where there is no structure even a kilometer long in the world, it is quite natural to ask how the Earth will bear the pressure of a structure made of thousands of kilometers. The international organization called International Space Elevator Consortium, ISEC, has been organizing various conferences related to the development of this elevator for the past several years. The meeting made up of engineers and scientists discussed various obstacles and possibilities. To make such a project successful requires sophisticated technology and a lot of research because the height of the elevator that is planned to be built will be about 1 lakh km. This height is more than twice the circumference of the Earth. And for this reason, the material of the elevator must be made of a material that has a relatively low mass but a lot of energy. Unfortunately, there is no such material in the world. This is the main obstacle behind the creation of a space elevator. In the early stages of space elevator research, researchers had very little hope for it because the obstacles were more than the possibilities, but with the improvement of technology, new hope was born in the minds of researchers, and this light of hope was brought by nanotechnology. Currently, researchers think that carbon nanotubes can be used as a material for the travel path of space elevators. This carbon nanotubes and its main structural material, graphene, are very light and flexible. On the other hand, it is about 200 times stronger than ordinary steel, so by using this material, the weight of the entire elevator can be greatly reduced. After removing the obstacle of making cables or tethers for the traffic path, what comes is the concept of tensile structure, i.e. how can such a large structure stay in one place without collapsing? This space elevator will basically be a flexible tower made of carbon nanotubes on which no gravitational force will act. One part of the tower will be on the surface and the other part will be attached to a heavy object. Centrifugal force will be created due to the presence of this heavy object. The heavy object will be placed in such a way that the resulting centrifugal force is slightly greater than the gravitational force, so that the tower remains stable and there is no risk of collapsing. Do not apply excessive pressure. Another major risk for space elevators is artificial satellites. Since the elevator's trajectory remains constant, there is a possibility of high-velocity collisions with moving debris and satellites that could tear the elevator's tether. American engineer and space scientist Jerome Pearson highlighted this issue. According to SpaceX, the rate at which NASA and other space agencies are building artificial satellites can cause serious problems for space elevators. Moreover, space debris from rockets also increases the level of risk several times, so with space elevators arrangements should be made in advance to avoid their collision. So far, the words said in the video may seem like science fiction to many, but in reality, efforts are underway to make this science fiction come true. The famous Japanese construction company Obayashi Corporation has announced that they will build this object by 2050. Again, China wants to build such an elevator by 2045. Although SpaceX founder Elon Musk has dismissed the possibility of building such an elevator, many engineers and scientists involved in the project believe that we could see a space elevator in our lifetime, perhaps in the middle of this century. This alternative route to space will be created. But this is my own opinion: is there a need for a space elevator at all? If the space elevator really does come out of the blue, it would be the largest engineering project in human history, costing an estimated $10 billion. But it is worth saying that the most expensive engineering project so far is the International Space Station. It cost about $150 billion in the efforts of various countries to build it. The cost of the space elevator is relatively low, and considering the financial aspect, it is not a very difficult problem for a developed third world country to build it. Although it is favorable in terms of cost, there are many risks behind the construction of this space elevator. As it is very large, it will take many days to complete the construction work. Apart from the construction cost, there is also the maintenance cost and the cost of the related employees. ISEC President Peter Swan claims that the cost of placing an instrument in orbit is $3,500 per pound of mass, and that this cost will drop to $25 per pound with the launch of the space elevator. Moreover, traveling by rocket is already very expensive and risky, requiring long-term training for astronauts. Also, a large part of the rocket is thrown into space before reaching the destination. Harmful. So if the space elevator is made, many of the negative aspects of the rocket will be freed. It will be possible to manage various types of risky missions easily, and this space elevator can also facilitate the desire of common people to travel to space. Many science fiction fans will have heard the name Arthur C. Clarke. This popular British author first described space travel with a space elevator in his book, The Fountains of Paradise, published in 1979. His scientific explanation about the space elevator attracted many scientists. Since long ago, people have been turning the science fiction of the pages of the book into reality. Only time will tell if it will be written or not.